Hey guys, welcome to my channel Calculus Diaries. Today we'll be looking at the derivatives of the inverse trig functions. So the first one we're going to look at is y equal to the sine inverse of x. How do we differentiate y equal to the sine inverse of x? How do we differentiate the inverse trig functions? First one, if we multiply both sides by sine of y, so the first one on the left hand side multiply by sine y, and the right hand side multiply by sine of the sine inverse of x. So we just like multiplying both sides by sine. So after this step, then a few things will simplify out. So the left hand side will remain as sine of y, and the right hand side sine of the sine inverse of x. It's like the sine and the sine inverse are cancelling out, so we are just left with x. So we can take the derivative here. So the derivative with respect to x of sine of y equal to the derivative of the right hand side, which is just left with x. Now we have to use a chain rule here, because we have to differentiate the sine function and differentiate the y, because y is a function of x. So using the chain rule, the derivative of the sine function, derivative of sine is cosine of y. But y is a function of x, which is gotten from the original function. So we have to differentiate y with respect to x. Equal to the right hand side derivative of x with respect to x is just 1. Now we can divide both sides by cosine of y. Cosine of y divided by cosine of y. So the left hand side is left with dy dx equal to 1 all over the cosine of y. So the derivative of the sine inverse of x is equal to 1 over the cosine of y, but we have to turn this into x. The function must be turned into a function of x. So we can do that by realizing that sine y was equal to x. That is from this. We can draw a right triangle. Right triangle. Our angle is y. Sine is opposite over hypotenuse. So if this is the angle, this is the opposite, which is x over hypotenuse. Hypotenuse here is 1 because x is just x over 1. So with that, we can use the Pythagorean theorem to find the length of the adjacent. So Pythagorean theorem is saying that the hypotenuse squared should be equal to the sum of squares of the other two sides, which is the opposite, which is x, plus this length here, adjacent. So adjacent, can call this one, let's say a. So this should be a squared. So a squared should be equal to 1 minus x squared. So if we want to find a, we take the square root on both sides, and that should be equal to the square root of 1 minus x squared. So this side is 1 minus x squared. So with that, we can find the cosine of y now. Cosine of y is equals to adjacent over hypotenuse. We now know adjacent as 1 minus x squared. Hypotenuse is just 1. So that is equals to, sorry about that, which is square root of 1 minus x squared, which is equals to the square root of 1 minus x squared. So now we know the cosine of y in terms of x. We can plug that back into our derivative function. So our final answer for the derivative of the sine inverse of x is 1 over the square root of 1 minus x squared. So this is the derivative of the inverse function, inverse sine function. So if we use similar methods, if you can find the derivative of, so if we have y is equals to the cosine inverse of x, the derivative of y with respect to x is just going to be the negative of this, which is negative 1 all over the square root of 1 minus x squared. So that is the derivative function of the sine inverse of x and the cosine inverse of x. So when y is equals to the sine inverse of x, the derivative is 1 over the square root of 1 minus x squared. If y is equals to the cosine inverse of x, the derivative with respect to x is just the negative of the answer in the case of sine inverse of x. So these are the two derivative functions in terms of x for cosine inverse of x and sine inverse of x. Now let's talk about tan inverse, that is tangent. When y is equals to the tangent inverse of x, what should be the derivative? Imagine this one, we can't use the power rule. We can't say dy dx is equals to negative 1 tan inverse. That is just by using the power rule, which is equals to negative tan to the negative 2 of x. So this is totally wrong. We don't do that. We use the same procedure, that is by multiplying both sides by tangent. So the first one is going to be, the left hand side is going to be tan of y multiplied tan at the right hand side. That should be equal to tan into tan inverse of x. So right hand side simplifies to tan of the tan inverse of x is just x, because this tan and tan inverse will sort of cancel out. So you are left with tan y is equals to x. So we can take the derivative on both sides. So d dx of the function tan y should be equal to d dx of x. And we utilize chain rule here again. We differentiate tan and differentiate y with respect to x because y is a function of x. So derivative of tan y, if we differentiate tangent, the answer for this is secant squared. Secant square y multiplied by the derivative of y, which is equals to the derivative of x with respect to x is just 1. So we can divide both sides by secant square y to isolate our derivative. Okay. So left hand side is dy dx. The right hand side is 1 all over the secant square y. So what is secant square y in terms of x? We don't know that. We have to evaluate secant square y in terms of x. So what that means is to draw a right triangle again. Put our angle here, y. This is tangent. Tangent y is equals to x over 1. Tangent is normally opposite over adjacent. Opposite is x, adjacent is 1. So how do you find the hypotenuse? So let's say the hypotenuse here is c. So using the Pythagorean theorem, c squared should be equal to 1 squared plus x squared. And that should be equal to 1 plus x squared. So c should be equal to the square root of 1 plus x squared. So the length here, c, is square root of 1 plus x squared. So with that, we can find secant square y. Let's find secant y and then take the square root. So secant y in this case, secant y is equals to 1 all over cosine y. So what is cosine y? Cosine y, cosine is equals to adjacent over hypotenuse. Adjacent, which is 1 all over hypotenuse. Hypotenuse is the square root of 1 plus x squared. So if cosine y is 1 over the square root of 1 plus x, then secant y, which is 1 over cosine y, should be equal to just the inverse of this one, which is the square root of 1 plus x squared. So this is secant y, but we need secant square y. So if we have secant y to be equal to square root of 1 plus x squared, then secant square y is just equal to the square of secant y. So we square that, and this is going to cancel the square root because square root is to the power 1/2, and that should be equal to 1 plus x squared. So we have gotten our secant square y, which we can plug into our derivative function. We can switch back to black pen. So we now have dy dx be equal to 1 all over secant square y. Secant square y is 1 plus x squared. And that's, we are done. So if we have y to be equal to the tan inverse of x, tangent inverse of x, then the derivative function with respect to x is 1 over 1 plus x squared. So with this, we can also find the cotangent inverse. So if we have y to be equal to the cotangent inverse, which is normally written as COT inverse of x, the derivative of this, the derivative of the cotangent inverse of x is equals to negative of the derivative of the tan inverse of x, which is negative 1 over 1 plus x squared. So that is the derivative of the tan inverse of x and the cotangent inverse of x. One is always the negative of the other one. So cosine is negative of sine and cotangent is negative of tangent. Now let's look at the last one, which is secant. Can scroll this up. Sorry about that. Can scroll this one up. And then I can use a blue pen for this. So if we have y equal to the secant inverse of x, how do you find the derivative of y with respect to x? So using the same principle, multiply the left hand side by secant of x, secant, and you do the same thing to the right hand side, secant inverse of x. Then the right hand side simplifies to just 1. Secant of the secant inverse of x is just x. Now we can take the derivative. Dx of secant y is equals to the ddx of x. Using chain rule here again, you differentiate the secant and then differentiate y with respect to x because y is a function of x. So differentiating secant, if we differentiate secant, the answer is secant y tangent y. Then you differentiate y with respect to x, which is just dy dx, equal to, when you differentiate x with respect to x, that is just 1. Now, I'm going to continue from here. You can divide both sides by secant y tangent y. Secant y tangent y. So this will cancel that. We are left with dy dx will be equal to 1 over secant y tangent y. But we need to change this in terms of x. We have to evaluate the derivative function. The function must be in terms of x, but right now we are having it in terms of y. So we have to change secant y and tangent y into x, in terms of x. The trick is here. As we have always done, we will draw our right triangle with our angle y. Secant is opposite over, secant is the inverse of cosine. Cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. So this is y. This is the right angle. Hypotenuse is going to be here, x. Adjacent is going to be here, 1. So how do you find the opposite? So we can call that, let's say, b, and use the Pythagorean theorem. X squared is equals to b squared plus 1 squared. So x squared minus 1 is equals to b squared. Then we can take the square root on both sides to get the square root of x squared minus 1 as the value of b. So b here is equals to the square root of x squared minus 1. So we already have secant y to be equal to x, which is from here. Now we can find tangent of y. Tangent of y. Tangent of y is opposite over adjacent. With this angle, this is opposite. Square root of x squared minus 1 all over adjacent. Adjacent is just 1. So this is just the square root of x squared minus 1. So that is the tangent of y. So now we have secant of y as x. We have tangent of y as square root of x squared minus 1. We can plug those into our derivative function. And we can finally arrive at the answer. I think I can do that here. Okay. So we have dy dx will be equal to 1 over secant of x. Secant of y is x times tangent of y is the square root of x squared minus 1. And this is the derivative of secant inverse of x. So if we have y, which is equals to the secant inverse of x, then the derivative of y with respect to x is 1 all over x square root of x squared minus 1. So y equal to secant inverse of x dy dx is equals to 1 all over x square root of x squared minus 1. What if we have y to be equal to the cosecant inverse of x? Following the same trend, the derivative of the cosecant inverse of x is equals to the negative of what we found, which is x square root of x squared minus 1. That is it. So to summarize this video, for all the 6 trigonometric function inverse functions, I can summarize them here for you real quick. So if y equal to the sine inverse of x, then dy dx equal to 1 all over the square root of 1 minus x squared. If y is equals to the cosine inverse of x, dy dx equal to negative 1 all over the square root of 1 minus x squared. If we have y to be equal to tangent inverse of x, the derivative of y with respect to x is 1 all over 1 plus x squared. If y is equals to the cotangent inverse of x, dy dx is just equal to the negative of that, negative 1 over 1 plus x squared. And the last set, if y is equals to secant inverse of x, this is x, dy dx is equals to 1 all over x square root of x squared minus 1. And lastly, if y is equals to cosecant inverse of x, dy dx is equals to negative 1 all over x square root of x squared minus 1. So these are the derivatives of the negative, the derivative of the sine inverse functions, cosine inverse function, tangent inverse function, cotangent inverse function, secant inverse function, and the cosecant inverse function. So these are the derivatives of the inverse function of trigonometric functions, inverse functions. So if you like this video, give me a thumbs up, like my channel, and drop your comments in the comment section and let me know where I can improve upon my video. Thank you so much for watching, and see you in the next video.